5 million to it. So here we go. Just to kind of practice, here's some properties from previous section on condensing. Because remember when we started these properties, you're going to be like, what's the point of these? Well, they're going to come into play today to help us simplify some of our equations so we can solve them. So let's just review quick. 2 logs added condensed to 1 log multiplied. Yeah. Log base 4, 5 times. Now let's get real. Am I going to leave it 5 times 2x? No, that bothers me. Let's make it 10x. Because we're going to want to, if we have an equation today, if that was in an equation, I want to condense it down to a single log if I can. All right, this one looks pretty simple, but we want to have a log of whatever. You want to do something with the 7, basically. Number down in front is really an exponent. So that was that third property, x to the 7th. And we're going to see this one, of course, today too. 2 logs subtracted condensed to 1 log what? Divided. And we're going to be fancy about it and use our fraction bar to represent division. Got it. So we're going to be using those properties again. That's why I just want to kind of do a quick review on those. Okay, so logarithm equation. So this should look kind of similar to yesterday. Obviously, I just kind of switched around from exponentials to logarithm. Logarithm equation is one in which the logarithm of the, let's put on this, variable occurs. So you're going to have log of x plus 7, log of x minus 8, whatever. Log of a variable. As always, just so they're in front of us, we can use some of our simplifying properties if we can. Your bases are the same, they cancel. ln and e cancel. We'll see this one for sure today. When you have the same thing on either side of an equation, those logs are going to cancel each other out. So you will see that again. So just throwing those on there so they're in front of us for the 50 millionth time. Now, yesterday I gave you guidelines for exponential. I'm going to give you some guidelines for logarithms. So simplify using properties of logs if necessary. This is why I gave you those warm-up problems. If you have multiple logs in there and you want to try to condense it down, 2 logs added, go to 1 multiplied, 2 logs subtracted, division, so on and so forth. Because you want to get to a situation where you have 1 log in it or 2 logs. And that's kind of where we're going to go here. If you have 1 log in it, you're going to put it into exponential. You're going to convert it. So we want to get down to 1 log or 2 logs. 1 log, go to exponential. 2 logs, if there are logarithms on both sides, then they just will simply cancel each other out. Now, before we actually get into any solving, or click the slide, let me ask you one other question we have to be conscientious of today. Can you do a log of a negative number? No. So yesterday, I didn't even bring that up to you because we had exponential equations. I can do exponents on anything. The domain's all real numbers on exponentials. Log is a problem. You cannot do a log of a negative number. So I am going to be conscientious of that and quote unquote check my answers today. I know none of us like to check. I don't like to check. But I'm going to make sure that if I plug it in for x, I don't have a log of a negative. There will be some answers today that we are going to be rejecting, just to preface this. Okay, so solve the logarithmic equation algebraically. Round to 3 decimal places, verify your answer, blah, 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 blah. Okay, here we go. So of course, I can't tell you what x is going to be. I can't do a natural log of something and come up to -4. Now, you're probably going to skip this step. But for the first one, of course, I'm like, okay, ln we know is a log base e. We know that. And then I'm going to convert this to exponential form. The base to the opposite side equals what we have left over. And I can type in my calculator e to the -4. That's why I've got the calculator up. Remember, I'm not going to type them all in, but I'll do a couple for you. Second ln, of course. There's the e. Make sure you use the negative sign, not subtraction. It will get angry at you. And it says to round to 3 decimal places. So let's put 0.018. So nice and easy to start with. We only have a single log. We can just convert it. It's not that traumatic. Okay. Now I'm just going to start now. Do a little quick mental check. If I put 0.018 in here for x, I do not have a log of a negative. So we're okay. I'm going to keep that answer, but I'm already starting to think about that. All right, B, we've got the ln, just some more numbers in it. Same thing. You're probably going to skip this step. It's really log base C. And then I'm going to go ahead and convert into exponential. E to the 1.5 equals 2x. And of course, you have one extra little fancy step here. You got to divide by 2 to get x alone when you're done. So let me give you a sec to punch that in and see what lovely decimal you get. You awake, everyone? Early? All right, what do you got? 2 point what?
241.
Got it. Now, before I circle it, just a little mental check. If I put 2.241 in here for x, are we okay? Do we have a log of a negative? Nope, we're good to go. But I'm going to start checking that. Yes, start checking that. It's going to be problematic at some point for us today. All right, I don't even want to say more fancy, just a little bit more work. Now, first question. Can I add 3 and 2 together? No, they are not like terms. One has ln, one does not. Get rid of the 3. Somebody wants to make it 5, and I'm like, oh, man. All right, 10 minus 3, 7. Now, of course, I'm trying to get the ln alone. I'm trying to get the variable expression alone. So I'm going to get rid of 2. You can leave it 7 over 2 or make it 3.5. I really don't care. You can use decimal, so I'm not sure decimal. Usually I do prefer fraction. Now, we don't want to have to obviously keep writing log base C. We got it. We know ln isn't a base E, so sometimes I just kind of sneak one on, and then I convert it. Okay, type that in your calculator, e to the 3.5. And what lovely answer do you get for that? 33 point what? 115. Okay, do a quick little mental check. Can you use that value for x? Yep. And I mean, really, if we're going to put a number on it, I'd say like 98% of the answers are fine, but it's always that lousy 2% that gets us. Okay, you might be looking at this. Same thing, nothing too crazy. First off, of course, I'm going to get the log by itself, so I'm going to divide off the 4. You could put the 4 on. I have had kids in the past that want to put the 4 on as an exponent, make it x minus 6 to the 4th power. You can do that, but you're going to have to 4 through it at the end, and it just seems like too much work to me. So I just like to cancel, but that is an option. Now, of course, 11 over 4 doesn't divide out. I'm just going to leave it. You can make it a decimal or, a mixed number, whatever you want to do. I'm just going to roll with it. Now, we've got our single log, so I'm going to go to exponential. 10 to the 11/4, which you can put in your calculator, equals x minus 6. So of course you're going to type in 10 to the 11/4, and I mean no magic here. I mean from here obviously I'd finish it in my calculator. 10 raised to, I don't even pull up the fraction bar or anything. I'm just going to do 11 divided by 4. Maybe, come on, fraction there. And then of course I'm going to add 6 over to that. You can hit plus 6 or just mental math that. So let's go 568.341. Okay, before I circle it, just a little mental check. If I replace x with that, are we okay? Yeah. All right, any questions on the first 4? I kind of like this stuff. It's not too bad. Just some decimal answers. Do most of the work in your calculator. Okay, more of the same. We're just going to get some larger answers here. Same deal. I'm going to one log. I convert to exponential. So 12 to the 6th. That's going to be a big number. Is what it is. Equals x squared. So choices here. Choices. You can of course square root right now, and then just punch in your calculator all in one step. The square root of 12 to the 6th. That's probably the quickest way to get to your final answer. And you obviously get a big number. So punch it in. What's the square root of 12 to the 6th? 1,728. And devil's in the details. I'm not going to circle this yet because what do I need in front of it? plus or minus. We're solving for a squared. We should have two answers. And, I know I'm still going, you love it. And let's just double check, is that negative 1728 okay? If I put negative 1728 and square it, it's going to be what type of number? Positive, which we can do the log of a positive, so I can use negative 1728. But I got to think about it. All sorts of good stuff, details there. Don't forget plus or minus. All right. Of course, we've got the log by itself. Big deal. We got a square root in it. I'm going to convert it. You're really log base e. I'm just going to sneak the little e in there instead of rewriting the whole thing. So e to the 5th, our square root, x minus 8. Okay. Well, we can do this. How are you going to get rid of the square root? Square. And you can type, you know, the left side in e to the 5th and then squared, but that seems like a lot of extra keystrokes. I would just make that e to the 10th, 5 times 2, make it easy on yourself, right? And then, of course, you're going to have to add 8 over to that once you punch all that good stuff in. All right, type that in. Ooh, you get a big number for this one, too, and some decimals. It's kind of yuck. Yeah. 22,000. What do you got? 34. We're lively today. What's your decimal point? Because we're yawning. 4, 6. Hey, thanks for that enthusiasm. Appreciate it, class. Any questions on that guy? Now, as always, you know, we kind of work our way from easy to a little more challenging and tricky. That's where we're getting to here. So, a little different. This is our first time we've seen more than one log in our problem, okay? So, first thing that jumps out to me is I see that log addition. So I'm like, all right, I got you, addition. I'm going to condense 2 logs added to 1 log multiplied. Can we distribute the x through? Sure. I mean, I'm probably going to do it at some point, but I'm just setting it up for now. So now I am just like the last problem. I have a single log. I'm going to convert to exponential. 3 to the 2nd. Yeah, I know it's 9. Then I'm going to distribute the x there while I'm here. So I'm like, oh, okay, fun. Quadratic. Back to chapter 1. We know lots of ways to solve quadratics, factoring, completing the square quadratic formula. Before we make a decision, let's subtract 9 over and set it to 0. Oh, judging by how tired we are today, I'm going to pray we don't have to use quadratic formula on this one. Does it factor? Anything multiply to negative 9 and add to negative 8? Yep. What are they? You got it. So here comes a dramatic question for you. You know I love the drama. What are your 2 potential answers for x? And which one of those do you think I have a problem with? Negative 1, because if I put negative 1 in here, I cannot do the log of a negative number. So I'm going to keep the 9. This is why I dramatically started checking the answers from the get-go. 99% of the time, it's not a problem, but every once in a while. Okay, ooh, man, a lot of logs in this one. We've got 3 of them. That kind of, remember, we want to have either 1 or 2. Definitely not 3, okay? So first thing that jumps out to me, you have these 2 logs subtracted. So I'm going to condense that down to 1 log divided. I'm going to use my fraction bar for that. Okay, so I've only done 1 with a log on either side today because it's so easy. If you have the same thing on the either side of an equation, they just cancel each other out. And now we have the fun-filled task of solving this equation. Well, just like any time you have a fraction in it, I try to clear it out. Let's multiply by the denominator. So I'm going to multiply each side by x minus 2. So of course on the left side, those x minus 2's will cancel. And then of course we're going to distribute the right side up. So I'm like, ooh, here we go, quadratic again. So we know lots of ways to solve quadratics, factoring, completing the square, quadratic formula. But before we decide, let's set it to 0. I like a positive lead term. It just, if I'm going to factor, makes it easy on us. So I'm going to zero out the left side. I'm going to subtract x, subtract 4. All right, so 0 x squared minus 3x minus 4. So let's decide, how's factoring looking for us? Pretty good, right? Thumbs up, I like it. What multiplies to negative 4 adds to negative 3? You got it. My dramatic question, as always, what are the two potential answers? What is your final answer? 4. Because we can't, if you put -1 in, you'll be doing a log of a negative number. Okay? There's the one really thing you have to be conscientious of, kind of checking your answers today. So any questions on the equation? Hey, let's hit the word problems, right? Now, the word problems and the graphing problem, easy. Obviously, the word problems are wordy. So just to show you too, and I really didn't address at the beginning ones, I said, you know, check on your graphing calculator, verify your answers. I want to show you how you can check your answers on your calculator for one, just if you want to double check it ever. Solve the equation graphically. Okay, so here's what you're going to do. In your, and I'm going to pull up my calculator, in your y equals menu, I'm going to put the left side in my y1, so I'm going to put x squared as y1, which we should just know right now what sort of shape of a graph is that going to be? Parabola. And then I'm going to put the right side as my y2. So I'm going to type those both in. I'm going to hit graph. And I cheated and I typed them in earlier because you know how slow I type on this thing. So type them in, hit graph. So our two, there's two answers. Our two answers are, of course, where those two graphs intersect, where the blue parabola meets that red logarithmic curve. And the great thing is your calculator will find it all for you. Okay, so to find these points, this is what I'm after. Let me steal the picture here. I'm after these intersection points. That's going to give me my two solutions. So my calculator is going to do it for me. You're going to hit second trace up at the top. Maybe second trace is 7. There we go. And I want number 5 intersect. You can arrow down, or I just hit 5. Now I'm going to do the left point first. You can see my cursor is already kind of over there. Just cursor them over close to the point. It doesn't have to be right on the point. It can be on the point, just close to the point. So you can see it's on the blue parabola. I'm going to try not to go on a rage about Texas Instruments, but I'm getting close to it. I feel it. I'm going to hit enter. It automatically now jumps to red. My screen shifted to red, so now it's on the curve, the LN curve. Hit enter. Nobody wants to guess. That's the stupidest thing ever. Keep the rage in. And there's our intersection point. Now, when I write down the answer, of course, I don't want the full point. We're solving for what letter? X. I only want the x coordinate. So I'm going to put down negative 0.712 for that one. Did it say what to, it didn't say what to round to, so whatever. Now I need to find the second intersection point. So I just repeat that same process. Second, produce, number 5. And I'm going to arrow over. I'm just right arrowing over till it's close to the point. Be nice if Texas Instrument had like touch screens and I could do it a lot better. But anyway, okay. So close to the point, hit enter. It's on the blue. It switches to the red. Nobody wants to guess. It's stupid. And there we go. And I just need the x. So 1.6. I'm just going to go 1.6. So you could, if you're on a test or quiz and you're like, oh my Lanta, I don't know, you know, if something's right, you could, I mean, even these. I could do y1 is the left side, y2 is 10, see where it meets. It should meet there, okay? So you can check all of these. That's, you're going to have to zoom out. Some of these big numbers, I'm like, man, you'd have to really zoom out, though, to see the intersection point. So that's kind of the one drawback. But I just wanted to show you in case you ever want to do that. Okay, let's get to the word problems. Oh, gosh, it's like reading a novel up here. Logarithmic equations are used in determining the amount of light that reaches various depths in a lake. I feel like I'm teaching science right now. This information helps biologists to determine the types of life a lake can support. As light passes through water or other transparent materials such as glass or plastic, some of the light is absorbed. It's easy to see that the murkier the water, the more light is absorbed. The exact relationship between light absorption and distance light travels is described in the next example. Here we go. Transparency of a lake. Let's do it. So if 10 and I denote the intensity of light before and after going through a material, and x is the distance, travels, there, the law, that very lovely Beer-Lambert law, I feel awkward saying beer in class, but there it is, where k is a constant depending on the type of material. Whew, okay, makes my head hurt. Solve the equation for I. Oh, thank God, something mathematical. I can solve for I. So we are trying to get this I by itself. So first, just so I have a little room to write, I'm just going to rewrite this equation down here. Now, I, not I sub 0, we're solving for. So first thing I would do, I'm trying to get the I by itself. As always, like all these other equations I was working on, I wanted to have the ln along. So I'm going to get rid of this negative 1 over k as my first mission. So I'm just going to multiply by the reciprocal. Because the k's will cancel, the 1's will cancel, my two negatives make a positive. I'm going to do the same over here. Now, negative k over 1, I'm just going to put negative k for this side. Okay. Gone, 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 gone. Down to the ln of I over I0. And I'm going to just put this as negative xk. So many letters, so little time. Now, just like all of our other equations, we have got this down to 1 ln. So I'm going to convert to exponential. It's really a base e, you know it. E to the opposite side equals this very lovely fraction. Looks like a hot mess. I feel like I'm working in circles and not getting anywhere, but I really am. Because man, I got one last step to get I by itself. I just have to get rid of this I sub 0, which I can just multiply each side, bless you, and do it. So I'm going to write it prettier because obviously I'm running out of room over here. So I'm going to put I0 e negative xk equals I. Got it. Okay, all right, wasn't so bad. Now, keep that, obviously, you have it. I'm going to lose it when I click the slide to the next one. I'm going to use this for part B. Because it says for a certain light, k is 0.025, so I'm going to replace that. I sub 0 is 14. Find the depth at 20. So I'm going to replace those numbers. I sub 0, I'm going to read it again, was 14, right? Yeah. Our time, our negative point, blah, 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 our times 20, we're going to fill in all this stuff. Here we go. So for a certain light, k is 0.025. You know what, let's just do this. So it's in front of us. I'm going to write our equation down. I can't remember all those crazy letters without it being in front of me. Okay, I0, 14. Got it. K 0.025. Got it. Crushing it. X, remember, if you read through that whole entire paragraph again, I'm sure you want to do that. X, of course, is the depth, so that's the 20 feet. All right. So all we have to do now is literally punch that into the old calculator, which I'm not going to bore you with because I know you can do it. You end up with about, it doesn't say what's around, 8.49. Got it. Lumen. Let's put a label, lumens. 8.5, whatever you want to round to. The key, of course, is the solving for I. Plugging the numbers in is pretty easy. No questions on that. All right, let's do some more formulas of money. Now, remember I said, God, it was 5 when I did a mental count. There are like 5 different formulas that you need for your test because we've done all these application problems. I didn't expect you to know 5 different formulas. I expect you to know how to use them. So we have seen already this one. We've already covered that one. I just threw it on here so it's in front of us. And you know, I might use it again. You just never know. So we've used this one. The first one to me is kind of just, well, obsolete really in a sense, because that's just this green formula with 1 year. It's just putting the 1 over 1, who needs the ones? This is the new one we're going to show you today. This guy. We're going to work on this. So this keyword here, continuously. So they are constantly compounding your interest into your account. And it will literally say the word continuously, which is your tip-off for using this bottom equation. Plus, I'm giving you the formulas on the test. Okay, other thing, the difference is we use the middle one if we compound it a certain amount of times a year, like quarterly, monthly, daily, whatever. Continuous, you're using the bottom one with the E in it. Just point that out to you. So here we go. Sum of 5,000 is invested in an interest rate of 5%. Find the time required for the money to, oh, that's fun, double, if compounded according to the following. Okay. Well, semi-annually. How many times is semi-annually? Twice. So that means we are using this middle green formula because it happens 2 times per year. So I'm using our formula we know and love. We're used to it. It's nothing wild or crazy. So find the time required for the money to double. Interesting. Okay. So we're starting off with 5,000. Remember, that's your P. 1 plus. Our interest rate's 5%. I'm just going to put it as a decimal. I don't have a percent key on the old graphing calculator. We already figured out the N. Semi-annual was 2. Remember, your exponent is NT, 10 times T. Now I'm rereading again. Find the time. That's what we're after. Oh man, I hear stuff dropping. Now, we can, well, I hope I have enough room here. I hope I left myself enough room. We can figure out the A, the final amount in the account. Notice I was dramatic about the word double. We gotta do a little mental math. If you start with 5,000 and you want it to double, how much are you gonna end up with? What's 5,000 double? 10,000. I should have left more room. I'm gonna sneak it in. There's a 10,000. I came up with that because it said double. If it said triple, you might see triple. What are you gonna put for triple? 15,000. Okay, good job, Owen. All right, so let's work on this. I would divide off the 5,000. I don't think we need a calculator for that, right? 10,000 over 5,000. Let's just go with 2. Now, I would type all of that into your calculator. So let me know that I really, I'm going to do, let's get out of the graph. 1 plus 0.05 divided by 2. That's going to give me some decimal. So 1.025. And we're raised to the 2t. So our goal, solve this equation. But I'm looking at it, first off, you gotta know your forms, obviously. We are in exponential form. I cannot mentally go through this and figure out what t is. We're stuck. So we're going to convert it into logarithmic form, like we did yesterday, and see if we can get it solved for. So this would be the log. Remember, your base is what has the power on it. Seems weird, but we can type that in. Equal to 2, and then we equal our exponent. Now, if this is kind of like messing with your head, which it might be, we are used to, usually we have it switched around. We have the exponential on the left. So our base 2 went to the left, exponent to the right, just for the sake of drama. Now that you can type in our calculator. So I'm getting in my math menu, letter A. I'm going to type all that stuff in, 1.025 for the base, 2, got it. And then I got to divide by 2, right? Yeah. And it didn't say what to round to. Oh, let's just make it easy. I'm going to say 14. 14 years. So this is why I said it's important that you know or you identify what form you are in. I was in exponential like yesterday, so I had to convert to logarithmic. And then of course vice versa. All right, clearly, continuously, we're using our lovely new formula there, the bottom one. We are still starting with our 5,000 for our P. Our rate's the 5%. We're finding the time, and we need the money to double. So once again, we're at 10,000. So obviously same numbers, just a different calculation, different formula. I'm going to divide off the 5,000 again. We are in exponential, so you're going to convert to logarithmic. But you would be in a log base E. I'm not writing log base E anymore, we're past it. What's a log base E? So I'm going to have the ln of 2 equals our exponent. And then of course we really can do this all in the calculator from this stage. And again, just to comment on the converting, if this is like, oh man, I got the things on the different side, we're used to, usually you have the exponential on the left. So then the 2 moves to the other side, 0.052 to the right. All right, punch that in. I don't know. What are you around? I'm going to go 13.86 for it. Didn't say what to round to. So, I mean, it's close. Quick question for you. What's the better way to go if you're trying to get your money to double? To compound it twice a year or continuously? Continuous. It's a little shorter. It's not a lot shorter, but it is a little less time to get you to your doubled amount of money. Always thinking about making the money. Okay, final little word problem of the day. Here we go. So, a sum of $1,000 is invested at interest rate 4% per year. Find the time required for it to grow to $4,000 if the interest is compounded continuously. So, of course, I'm just going to jot down the formula so it's in front of us. I want to click back 3 slides just to get to it. So, sum of $1,000. So that's our starting amount, our P. Our interest rate, 4%, 0.04. Got it? Find the time. So we're finding T. T stays as T. And we want to end up with $4,000. So from here, I'm just going to go through and solve my equation. It's not magical. I'm going to divide off the 1,000. 4. Now again, just know your forms. You're an exponential, so we're going to switch into logarithmic. We're not going to write log base E, we're past it. So I'm going to have the ln of 4 equals the exponent. And then of course just divide off 0.04. All right, what do you got for your final answer of the day? Round to whatever, surprise me. 35, I heard. I'll take that. 34.66. I don't care. Man, think about that. Is that a long time to have your money invested? To get $1,000 to go to $4,000? That is depressing. But that's, yeah. Okay.